Okay, so the first thing you'll need to do if you haven't already is download and install Android Studio. Just go to Google and type in Download Android Studio, click on the first link, and that'll take you to this page where you can download Android Studio for your system. Now, this download can take a while, so you might want to pause the video while you're waiting. After you've downloaded and installed the program, go ahead and launch it, and you should see something like this screen. Just click OK to say that you don't have any settings to import. With Android Studio, you can create apps for lots of different types of devices: smartphones, tablets, watches, televisions, cars, and even Google Glasses. Now this next screen will ask you what type of installation we want. We can choose either standard or custom. We'll go ahead and select custom because that will let us set some options that will save us time later. Next we need to choose whether you want the light or the dark theme. I like the dark theme. It's a little easier on the eyes if you're staring at the screen for a long time, but you can always change it later. Finally, you're asked if you want to download some different components. These components we'll have to download eventually, so we might as well do it now. You should check every box. These are things that we're going to need for testing out our app once we've written it. So go ahead and check all those and then click Next. And then click Finish to confirm. And now it might be a good time to go binge watch something on Netflix because this part will take a long time. So pause the video, come back when everything's downloaded. Once you see this screen, that means everything's done, so click Finish, and you'll be greeted with the welcome screen, and now you are ready to begin your first Android Studio project. So we're going to start by creating a new Android application, and the first thing we need to decide is what the app's going to be called. It doesn't really matter what we put here. It should be something interesting that describes the app. We can always change this later if we need to. For your company domain, you can also type whatever you want. Android Studio uses this and combines it with the application name to create what's called the package name. The package name has to be unique for every application installed on a device. So if you have a website address, go ahead and type that in here. If you don't have a website address, just put your name.com and that should probably be fine. So you can see as I change this value how it changes the package name underneath. That's the unique name that we need for our app. Now the project location underneath is going to be just where the application is going to be saved. So we'll click Next, and we're taken to the target screen. On the target screen, we're asked what type of device and what version of Android we want to target with our application. We can select any version of Android we want, but whatever version we select, our application will only run on that version and higher. As we change this setting, Android Studio will tell us what percentage of devices in the world will be able to run our application. Selecting a lower number allows us to run on more devices, but selecting a higher number gives us access to more features. Now, there are a few different schools of thought about which version of Android to target. Some people say, take the latest version, go back one, and that's what you should target when you're creating a new app. Other people say you should target the earliest version that you possibly can that still allows you to create an app that does everything you want it to do. In our case, we're going to go ahead and select Android version 6, just because that's the version of Android I have running on my phone. If you have a different version on your phone, you should pick that. Now, once we've chosen that, we'll go ahead and click Next, and then we're taken to the activity screen. In Android, every screen you see in your application is called an activity. Android Studio provides lots of different activity templates we can use to start our app, just to kind of kickstart it a little bit. But here we're going to choose just the empty activity. We'll explore some of the other types in future classes. But for now, choose empty activity and go ahead and click Next. Now, every activity has two different files associated with it. One is called the code file or the Java file. That's the one listed here as main activity. And the other file is the layout file, here as it's called activity underscore main. Now we're going to let Android Studio create both of those for us just to help us out a bit. We'll click Finish, and then we'll wait a little bit while Android Studio creates all the different files for our program and connects them all together. Now, once the application starts to load, you'll notice a lot of the code is red, showing different error messages. There's a progress indicator at the bottom of the screen. This is happening because Android Studio is indexing the project and figuring out where all the files are and synchronizing everything. So we want to wait until that process is finished before we start editing anything. So we just wait for those progress indicators to finish. The code will change from red back to normal. You'll see the final indexing screen scroll across the bottom of the progress bar, and then once progress bars are finished, we're ready to start. Now you should see an editor here on the right and on the left a list of files and folders. If you see something like this where you just have the editor, click on this project tab, and if it's set to the default project view, we want to switch that to the Android view. That'll make it easier for us to find the files we want. And this is the view we should have when we start working on our project. Every screen in your Android app is made from two files, an XML file that controls the appearance and a Java file that controls the behavior. The XML file is sometimes referred to as the layout, while the Java file is referred to as the activity. The Java file for our main activity is shown here in the editor when we first launch the program. The layout or XML file can be found in the resources directory under the layout folder. Android Studio provides multiple ways for looking at our layout. This side-by-side view shows the preview of the layout as well as a wireframe mockup. We can toggle back and forth between just the preview, just the wireframe mockup, or the side-by-side view. Most of the time we'll be working just with the main preview. Another view of our layout we'll work with is the text view. Clicking into the text view shows us the raw XML code that generates the layout. The design view shows us the preview of that layout. Again, most of the time we'll stay in the preview mode, but sometimes we'll switch over to the text view in order to do some fine-grained adjustments. All of the screens in our Android app are comprised of layout containers. These containers hold controls that display things on the screen, such as text or buttons. When we have text on the screen, for example, it's held inside of a control called a text view. Likewise, when we have a button on the screen, it's held inside of a control called a button. These controls contain properties that we can modify in our layout file in order to change their appearance. If we click on this text inside of our layout, we'll see that this is a text view, a control that contains information about text to display in our layout. The main property for text views is the text field, but we also care about the ID of the text view. By setting the ID of the text view, we'll be able to connect with it in our code file. We can use any unique word to define our ID so long as it doesn't contain spaces or other special characters. Many people like to add a prefix to the ID to indicate what type of control it is, such as txt for a text view. We'll also change the text of our text view. Instead of just saying hello world, we'll display a message to the user. Don't tap the button. When we modify this property, notice how it's immediately changed in the layout as soon as we leave the text property field. By default, the text view is just big enough to hold the text, which is what wrapped content means. We can modify that to match parent, which will make it big enough to fill the entire width of whatever container it's inside. We can then center the text and modify its style, making it bold and slightly bigger. We can also modify the color of the text by clicking on this box next to the text color property. We're given a list of predefined Android resources. By selecting color, we'll see a list of all the different colors that Android Studio has predefined for us. These are colors built into the Android system. We can select this nice red color, or we can define our own. For now, we'll select one of the pre-built ones. Notice again how the text immediately changes in the layout preview. Next, we'll add a button to our screen. We'll go over to the widgets list, a list of different built-in controls, and drag a button onto the screen. Notice as we drag it around, layout guides help indicate how the button will be laid out on the screen. These layout properties are important because our app needs to work and look good in various screen orientations and in different device sizes. Android Studio will let us preview how our app will look in different device sizes, such as a tablet in landscape mode compared to a phone in portrait mode. Notice how when we select an item in the layout, the Properties Inspector changes to show the properties for that item. We'll give our button an ID of the button and modify its text to say, Tap Me. An important thing to note is as we change these properties, it appears that the layout preview is changing. But what's actually changing is the text that generates that layout preview. For example, here is the XML code for generating our text view, and here is the code for generating our button. Notice that the text has been set to Tap Me. If we modify the text directly in the XML file and then switch back to Design View, we'll see those changes have been made there as well. Changing it back immediately reflects the change in the designer. We can also change the layout of our button in the designer. by moving it up closer to our text view. And then if we switch back to our XML look, we'll see that those changes have been reflected in the layout properties. No matter how our device orientation or size changes, our button will always be 61 pixels below the text view. For now, let's put it right back in the center of the screen. There are two main ways to test your Android app. First, if you have an Android device, you can set it into developer mode, plug it into your computer with a USB cable, and test it that way. But if you don't have a device, you can test your Android app using what's called the Android Emulator, a piece of software that's built right into Android Studio, which simulates an Android device right on your computer. First, we'll look at how to test your app using an emulator. Then we'll look at how to test it using a real device. To get started, click on the green arrow at the top of the screen that will bring up the deployment target window. Since we've never used an emulator before, this window is currently empty, showing no USB devices or emulators. To create an emulator for testing, we'll click the Create New Virtual Device button, which will bring up our hardware selection screen. We can choose to emulate any type of Android device that's built into Android Studio, from tablets to phones to TVs. For now, let's just choose the Nexus 5 and click Next. On the next screen, we'll select which version of Android we want installed on the device. We can pick any version, but some of the versions we'll have to download beforehand. Since we already have version 7.1.1 downloaded, we'll go ahead and test with that version and click Next. On this screen, we can specify additional options and give our emulator a name. You can just leave it with the default name, or name it something that will help you remember exactly which version of Android you have installed and other device options. Once we're all set, click Finish, and our Android emulator will be created. Now our newly created emulator shows up on the screen as an available virtual device, so we'll select that and click OK. Now we only have to go through this process one time. After that, this virtual device, this emulator, will always be available, but we can create new ones if we need to. Once we click OK, Android Studio will start building and launching our emulator. Now this process can take a considerable amount of time the first time you run it, especially if you're running Android Studio on a lower budget PC. This little notification pop-up we see in the top right about Gradle invocation finished just means that our application built correctly and there are no problems with it. So we'll just wait for the emulator to load, and then Android Studio will copy our application onto the emulator. Once the emulator does load, you'll see that there are several different controls connected to it that we can use to interact with the device. And as we move the emulator screen around, those controls will follow it from side to side. If we click on the orientation buttons, we can simulate rotating the device into different directions. We can also power it off, adjust the volume, take a screenshot, zoom in, and also interact with the home screen buttons that are available on all devices. Once the emulator finishes booting up, Android Studio will begin copying our app to the emulator. You can see kind of the status messages here along with the progress bar. Eventually our app will appear on this screen. And there it is. And then we can interact with it just as if we had a real device. Now right now our app doesn't do anything, but it does look and behave exactly like a real Android device would. And we can interact with the phone just like we would. Tap the home button to come back to this screen. We can swipe up using our mouse, find our app in the recently used app list, and rerun it. Now, since the emulator typically takes a little while to get up and running, my advice is not to quit the emulator. Don't click the quit button, just click this red square in the top of the Android Studio window. That disconnects Android Studio from the emulator. We can also minimize this emulator status window by clicking on this button on the right-hand side. The next time we want to test our app, since the emulator is already running, the process will go much more quickly. In order to make our application do interesting things, we now have to connect the layout elements to the code. Remember how we gave each item in our layout an ID? When we compile the app, Android Studio collects all those IDs and puts them together into a resources list, organized by the ID name. In order for our Java file to be able to modify those elements, we have to use a function called findViewById. This command will allow us to access those items in the resources list. To use it, we first type out findViewById and then tell it which ID we're looking for. Android Studio provides a convenient way to do this using the R object. By specifying r.id.textMessage, we can access the resource with the ID of text message, which corresponds to a text view in our layout file. Once we have that resource, we can then store it inside of a variable of the correct type. This will allow us to modify the properties later on in the code. Here we're going to store it in a variable called MSG, which is just short for message. Notice the type of variable is text view, the same type of thing we put into the layout. With this stored, we can modify the properties of the control directly in our code, which will then change how the app looks and behaves. We'll use this pattern over and over again in our Android development. So to add the behavior to our app, we need to modify the Java file that goes with this screen. You can find it in the Java directory. Now there are 3 directories here. We want the one that doesn't say test. Inside of there is a file called main activity, and this contains all of the behavior for that main screen of our application. Switching back over to the layout, we'll select our button control, and we'll verify that we know what the ID of the button is. Now we'll go back to our Java file, and whenever we modify the Java file, it's nice to put in a little comment, just a little message to ourselves reminding us of what we're doing. We can create a comment by using 2 forward slashes. Anything we write after those slashes on the same line is ignored by Android Studio. Now make sure you add the code in between these 2 sets of curly braces. These belong to the onCreate function, the function that's going to run automatically when the activity starts. Now, as I mentioned in the introduction, when we use the findViewById function, we need to store that view into a variable of the correct type, which in this case is going to be button. Unfortunately, when we use button, Android Studio tells us it doesn't know what a button is. That's because this file is missing the statement that tells Android Studio how buttons work. If we hover over the button text, we can see that there's a way to add this automatically. To do so, just hold down the Alt key or the Option key if you're on a Mac, and press Enter. Android Studio will then automatically add the correct import statement to give you access to all of the properties that a button has. Another shortcut you'll notice as we start typing, if Android Studio recognizes the function we're trying to use, we can press Tab or Enter to automatically finish typing that function. Now we've connected the button from our layout to a variable called the button inside of our code. However, before we can use it, there's still one more thing we have to do. See this red squiggle that indicates an error. This particular error is caused because the findViewById function returns a generic view, but we're expecting something we can store as a button. So we have to tell Android Studio that we know that this ID corresponds to a button. We can do that through a process called casting. Now if we tap on this and press Alt-Enter or Option-Enter on a Mac, once again Android Studio will automatically fix this error for us. We'll just select Cast to Android button, and then it'll insert the correct code to make this line work. When we're connecting things between the code and the layout, we need to make sure we know not only the ID, but the exact type of thing we're connecting. So when we click on our message here at the top, we can see that the type of thing is a text view. We can see that shown here on the left inside the component tree, as well as in the XML view. Switching back over to the designer, we can also verify the ID, and then come back to our code and repeat the exact same process we used for connecting the button, including using our Alt-Enter or Option-Enter shortcut to import the correct library, creating the variable name, and we'll go ahead and cast ahead of time since we know we're going to have to do that, and then use our findViewById function to access the correct resource from our layout that we want to connect to. Now notice here I used a different name for my message variable than I used for the ID of the text message. These don't have to be the same, but it's usually best practice to make them the same. So we'll go ahead and change that, and now we'll add the behavior for our button. What we want to do is when the button is tapped, we want to change what's inside the text message. An important concept in Android development is the concept of event listeners. When certain actions take place in our application, such as tapping a button or swiping the screen, that is called an event. We can create event listeners designed to listen for specific types of events. For example, when a button is tapped, we could have something called an on-click listener set up to listen for that event, so that when we tap the button, the listener will be notified, and then the code inside of the listener can execute, affecting how our app behaves. Coming back to our Java code, we can create an event handler or button listener by starting typing set on. Android Studio will provide us a list with all the different types of event listeners available for the button. You'll notice there are a lot of different event listeners, one for each type of event that a button could particularly create. In this case, the default one is listed at the top, and that's the one we're going to use, Set on Click Listener. There's a fair amount of code that goes in an event listener, but if we start out by typing new on and then press enter, Android Studio will create all of the code scaffolding we need to create an event listener that will respond to the button's on-click event. Now once again, our goal is to change the text when the click happens. So we're going to get the text message variable and say text message dot set text. Then we'll put the string of characters that we want to display when that happens. In this case, we'll say no. So let's review what we've done. We started with a button, which we connected to the layout using the Find View by ID function. We also got a reference to our text view, which contains the message that the user is going to see when we tap the button. We added an on-click listener to our button so that whenever someone taps the button, the code inside of the on-click event will execute, setting the text of the button. Once again, this is a general pattern for Android development. Get the views using their IDs, add some event listeners, and then have code that executes in response to those events. Test our app again by clicking the green play button, selecting the emulator we created earlier, and clicking OK. If we can't see our emulator, we just need to select it since we left it running, and then Android Studio will begin copying our application over to the emulator, and then we'll launch it. Once our application launches, we can tap the button and watch the message change in the text view. Congratulations! You just created your first Android application. Once again, don't close the emulator in case you want to make some changes. Just click the red stop button and you can modify the code, you can modify the layout and play around and see what else you can create. Now if the emulator is not working for you, or if you just want to test with a real phone, you can do that by going into your settings and then scrolling down until you see the About button. Tap that and scroll down to the build number and tap it 7 times. You should then see a message that says you are now a developer. That puts your phone into developer mode. Back up one screen, and then in your settings, you'll see a new option, Developer Options. Tap that and scroll down until you see something that says USB debugging. Switch that on, and that will allow your phone to connect to Android Studio so that you can copy applications to it directly from your computer. The last thing you need to do is just plug your phone into your computer using a USB cable. You should be ready to go. Now, when you're in Android Studio and you click the green play button to test your application, you'll see your phone listed in the available devices list. Notice how it shows with a blue rectangle instead of a purple to indicate that it's a real device. Now, if you don't see your phone in that list, the problem is probably with your USB cable. Not all USB cables are created equal. In order to save money, some manufacturers will leave out wires in the cables, only including the ones necessary for charging your device. But in order to connect to Android Studio, you need a real data USB cable. The best option is to use the one that came with your phone. Now once your device is in the list, if you click OK and the screen shakes and gives you a red error message, this means that the minimum SDK version or Android version you selected for your app is higher than the one on your phone, which means that your phone is too old to run your app, but we can fix that. All you have to do is go over to the left and select the option for Gradle scripts. Gradle scripts are files that contain information that Android Studio uses to build your app. In this case, we're going to want the second option on the list, not the top level build file, but the one that says Module App, the second one. Here, you'll see that there's a Compile SDK version and a Minimum SDK version. We want to change the minimum version to the one that your phone supports. Once you've done that, click the Sync Now button, and then wait a few seconds while the application resynchronizes with the new script. Once that status bar disappears, click the green play button at the top of the window again, select your phone in the device list, and click OK. Android Studio will then ask you if you want to install the Instant Run library. Installing this library on your device will allow you to copy changes from Android Studio to your device much more quickly. But for now, we'll just say proceed without it. You can always add it later. Android Studio will then begin building your application, and once it's finished, it will install it on your phone, and you'll be able to test it out just the same way you'd be able to use the emulator. However, what's nice about this is the application is now permanently installed on your phone until you delete it. So you can disconnect the USB cable and show your friends and family the great Android app you created. Now let's make our app a little bit more useful. So we'll switch back over to the Java tab, and instead of just setting our text to this static message that we're going to use every single time, let's change it up a little bit and make it so that our app can tell a joke. Now to set this up, we're going to use something called strings. A string is a type of container we can use in Java to hold some text. So we'll create something called a static final string, which is a technique we use in Android development when we want to create a string that we're going to use somewhere in our app, some text we're going to use, and we want to be able to refer to it by a name. In this case, the name is going to be question 1, and the question string, the text we're going to use, will just be knock knock. This will be the first question of our joke. Now we'll create another static final string called answer1, and this is the text we're going to show on our button. So when we press this button, it'll be like we're giving this answer, and the answer will be, who's there? Classic answer for a knock knock joke. The questioner will then respond with the second question, which will be boo, and then we will give the classic response to the knock knock joke for answer number 2, which will be boo hoo. And finally, the questioner will give the punchline for question 3, which will be, why are you crying? Not the funniest joke, but it'll demonstrate the point. So there are the strings we're going to use for our joke telling app. Let's go ahead and get rid of this old code that we have inside of our onClick handler. And now, before we set up the click handler, we want to create the starting text for both the message text view and the button. So we're going to set the message text view to be starting with question 1, and then we'll set up the button so that its text will start with answer 1, so that when we launch the app, the message will say knock knock, and the button will say who's there. Now previously, when we tapped the button, the onClick handler would run and change the text of the message. But now, we're going to want to change the text of both the message and the button, but we're going to change them to different things depending on where we are in the joke. At the heart of our joke app will be an if statement. An if statement is a block of code that says, if this certain condition is true, then execute all of the code inside of this block. We can also tag on an else statement, which says if that condition is not true, then instead we should do this other block of code. This is how we're going to set up our knock knock joke application. So inside of our click handler for our button, we're going to use an if statement and find out what the current value of text message is by using the getText function. We'll then compare that to our first question. If those are the same, then that means it's time to move on to the second part of the joke. Notice inside of our if statement that we have to use a double equal sign to test if two things are equal. That's because a single equal sign will make one thing equal to another, whereas a double equal sign will just compare if they are equal. So if our message text is currently on the first part of the question, we want to set the message text to the second part of the question, and then we want to set the text of the button to the second part of the answer. So now our question message should say boo, and our button message will say boo hoo. Now when we tap the button again, we'll want to move on to the next part of the joke. So we'll add another question here using else if that will say if the first condition isn't true, then let's check the second one to see if the message is currently set to the second question. Now if that is true, then we're going to set the text view to the third part of the question, and we'll set the button text to the third part of the answer. So in this case, the text message should now say, why are you crying? We don't actually have a third part of the answer for the button. Instead, we want the button to let us start the joke over. So we'll add the third answer string to the top here, setting another static final string, and we'll just have it say start over. And then if we're on that final part of the joke where the message text is showing the punchline, we'll change the button text to say start over. We'll add a final else clause here so that if we are now on the last part of the joke, we will set the text view back to the first part of the joke and the button back to the first part of the answer. This way, we can go through the joke as many times as we want, and it will always start back from the beginning. So let's review briefly what we've done. First, here at the top, we created a bunch of static final strings to be able to cycle through as part of our joke. We set up the initial strings that our text view and our button would use. Then in our onClick handler, we set up a bunch of conditional expressions using if statements to be able to change the text of the text view and the button depending on what part of the joke we were on. So now, let's test it out. Click the green button at the top of the screen, select your emulator or your device and click OK. And if your emulator is not showing, select it. And now we can see our knock knock joke. And when we tap our button, we're going to be able to cycle through all the different parts of our joke. And we can run through this as many times as we want. So now you know how this process works. You can go into the code and change the text of the joke just by changing these message strings that we created at the top. Or you can change the entire format and do something different by switching up how the conditionals work. Experiment and post your ideas to the class. So now that our application is more functional, let's work on making it a little bit nicer looking. First of all, let's style this background. So instead of a plain white background, we might want to change this color. Now you'll notice that in the properties view, there are actually no properties related to the background color. That's because when we click on an item in the designer, it shows us just the properties it thinks are most relevant for that particular type of control. If we want to see all properties, we can click either the View All Properties link or this double set of arrows at the top. Once we do, we'll see the complete set of properties related to the view that we've selected. I'm going to go ahead and click on the background, and I'm going to set its color to use the primary dark color. Now, those predefined colors are defined in the Resources directory underneath the Values folder. There's a file called Colors, and in here you can see 3 colors defined for our app. The primary color, which is used for the action bar at the top of the screen, the primary dark color, which we've just selected, and then the accent color, which is used for controls that need an accent to offset it from the background. Now coming back to our application screen, so let's select our text and get rid of that garish red color and just make it a nice white. And we'll go back to just the standard set of properties. And we're going to make that text a little bit bigger. Let's make it 50. And we will not bold it. And instead of sans serif, we'll go with sans serif light, which is a little bit thinner of a font. So now let's work on this button. So when we click on the button, we see that it's a very plain button. It's not the standard material design style of button. If we go up here to the Style drop-down, we see that there are a few different options we can choose from. Let's select the App-Compatible Button Colored option. You'll notice that the color of the button is now the same color as our accent color in our colors.xml file. So now that we've got our button styled, let's go ahead and move it a little bit. So let's slide it down here until the layout arrow shows it as an offset from the bottom. And then if we switch over to the text view, we see that now we've got it's aligned to the bottom, but with a margin of 89 pixels. If you ever see this message, you can just click the refresh button, and usually that'll clear things up. Sometimes the layout designer gets a little out of sync with the XML. Let's make the text in the button a little bit bigger by changing the text size. Now if you don't like the all caps look, you can toggle that off in the text style property here. We'll leave that on. And then let's go ahead and actually bump this up a little bit bigger. We'll set it to 70. So now let's go ahead and run the app in the emulator and see how it looks on a real device. When that's done building, it'll launch. Notice our knock knock joke text is there. You can tap that button and get our answer. We can cycle through the joke, and our font and our colors look a lot better than they did before. Now, one problem we had with our app is that every time the text changed for the button changed size. That's because the button layout width is set to wrap content, which means it will be just wide enough to hold the amount of content inside of it. We can fix that by setting it to match parent. That will give the button a fixed size, which will take up the entire width of the screen. Now, that might be too big in some situations, such as this one, where it looks a little bit strange. Also notice that in landscape mode, our button comes way up overlapping the text. That's because of the margin between the button and the bottom of the screen. So let's fix both of those problems. Now we can fix both of these problems using the layout margin. Let's switch over to all properties, expand layout margin, and let's set the bottom layout margin to just 10 device pixels, and we'll set the left and right to 30. That will shrink the size of the button. When we switch to landscape mode, now we're no longer overlapping the text up here, and also we are no longer extending all the way to the edge of the screen. Let's make one more change with our text. We'll click on that and go back to just the standard set of properties, and we'll change it from sans serif light to an even thinner font using the sans serif thin font setting. That'll make the text crisper and take up less room. And now we're ready to test again. Now there are lots of other customizations you can make to your app, fonts, colors, styles, other controls you can add.